Okay, hi everybody. You just heard a few bits about me, I think. I've got a few more to share, but well, I've been programming for a long time, my whole life. I've done just about everything. I've worked at Microsoft, I've worked at Apple, I've done everything I can think of, I think. And I've ended up doing a lot of Swift work. I can honestly say that out of all the languages I've ever worked in, it's probably my favorite. And as I think is pretty obvious here, I'm a big fan of Swift on the server side, which, for those of you who are not familiar with it, refers to using Swift mostly on Linux servers for hosting web applications, APIs, that sort of thing. Things that we traditionally use things like Ruby on Rails, Node.js for. And I think it's impatient. But as it says, in my opinion, Swift on the server is the best kind. It makes for better ways to write the language. And oh, wow, very impatient slide. I know it's a pretty strong statement to make to say that it's definitely the better one, but I have reason to think so. But first we need to start with a little history of where Swift came from and some of its predecessors. And here we are. For those of you who are not familiar with the history of macOS itself, it was like AppKit, like it says AppKit was here. macOS evolved from the Next Step OS and OpenStep API that Next was developing in the early and mid 90s. AppKit itself goes back that entire way. Was designed for the original form of Objective-C, which was based very heavily on Smalltalk in turn. And a lot of things haven't changed in all that time. It's a legacy, definitely. It comes with a lot of very old ways of thinking about things, a lot of old ways of doing things. That's layered on top of Foundation, which has even more of the same, really. It's still usable for writing UI on macOS, but it's not the easiest way of doing things, definitely not anymore. And less and less people are doing it now, simply because it's not. It's also macOS is not as popular as the mobile ecosystem has gotten, which brings me to UIKit. And this was released with the first iPhone SDK in 2008. It was not based on AppKit in any way, at least not in terms of sharing code with it. I don't know exactly what went on internally as far as the first implementation. I would guess they probably did copy a few things, but it's designed completely differently for a brand new kind of UI. At that time, iPhone was a completely new thing. It was the first framework alongside the iOS SDKs in general to leverage the new version of Objective-C that Apple came out with at the time, 2.0. And Objective-C 2.0 had a lot of improvements over the old one, the not fragile API, which meant that the sizes of things could change without having to recompile every single library in the entire OS to deal with it. Lots of other features, better ways to specify properties, better handling of reference counting, all kinds of things. The one thing that those who have worked a lot with UIKit have found is that it changes a lot over time, and it can be really difficult to keep up for some of us. But it does still use the same way of building user interfaces, which is what used to be called Interface Builder and is now integrated into Xcode as the visual tool that most of you have probably used for designing storyboards and nibs. But it's all still built on foundation in the end, which means, among other things, that it's all still, how to say, it's still all stuck with the old legacy ways of a lot of things. And also, I mean, that's true of Interface Builder too. Even with storyboards and view controllers and connections and segues, there's still a lot of very old ways of doing things that are embedded very deeply in both AppKit and UIKit. So again, it can get fairly complicated to do even simple things, especially in Swift, where, well, I'll get to that in more detail soon, but to summarize, Swift is a very different language than Objective-C, and it has very different requirements. So the end result is things get a little awkward. And in the meantime, well, yeah, I know. We all want to know what's about Swift on server. Why am I talking about UI frameworks? Well, the reason is because the legacy on which it's all built is important for understanding why it's better on the server. And how should I say? Well, it'll make sense in short. So Swift came out in 2014, or at least it became open source at that time. A brand new language, had all kinds of new things in it. It still does. All kinds of things Objective-C couldn't do, but one of the things that was very critical about Swift when it first came out was that it was interoperable with Objective-C and all the old frameworks, especially UIKit and AppKit, from the very beginning, and that was an explicit design goal for Swift, at least early on. And this influenced the language in certain ways, but the language was nonetheless intended to be portable pretty much anywhere eventually. Has, as we all know, the community-driven process for changes, evolution, and most importantly, it has a safe, but, well, at least a more safe by default way of expressing a lot of things. A more powerful type system for working with just about any kind of type, as we saw just then. Enums have a lot of variable, very great power. That kind of enum just didn't exist in Objective-C, for example, along with reference types like structs, at least not in that form. Sorry, not reference types, value types like structures. Classes are the reference types. So Swift ended up being originally supported only on Mac OS. Linux support came along, but not instantly. And it was a revolution in a lot of ways, and it's still being one. But among other things, it immediately had broader applicability than just about anything Objective-C was useful for. Objective-C was very broadly dependent on things like foundation and, to a lesser extent, UI frameworks like AppKit and UIKit. Swift does not have that. Swift only needs its own standard library. And of course, Foundation provides a lot of very useful tools, but they're not required. And that makes Swift a lot more powerful in a lot of ways just by itself. It's possible to use it as a scripting language, or at least it's sort of possible at the moment. It certainly will be more possible in the future. It's, and as this talk is about, ultimately, it's also possible to use it for server-side development. You're not going to be able to run modern Objective-C code on Linux, at least not in the form, not in the familiar form that you find in macOS development, certainly. So the new language came with a lot of new directions, new capabilities, new ways of doing everything. And I think that there's been a lot of discussion of things like that during the talks in this conference. And another one of those is Swift UI, which Apple designed completely around Swift, which it's the first UI framework, at least designed by Apple, that actually takes advantage of the language. And it's hard to even begin to get into how many ways in which that changes how the UI gets expressed. There's no interface builder. There's no familiar visual tool for building interfaces, although there are visual tools in Xcode. SwiftUI has the preview viewer, which some of you may be familiar with. And in general, the most important thing about SwiftUI is that it works everywhere. SwiftUI, you can write one user interface and it will work on macOS, it will run on iOS. It might not look the same, it might not work quite right, but it'll run and it'll function. And it does. SwiftUI, I cannot overemphasize how much it takes advantage of the capabilities of the Swift language. Specifically in ways that the old UI frameworks just can't, because they'd have to be rebuilt from ground up in a way like this in order to do so. There's no outlets, there's no need to deal with optionals so much. It's very different, it's a completely different syntax. There's even been a few language features that have been added to Swift specifically to support SwiftUI, although they have much broader applicability, things like property wrappers and function builders. And more recently, the multiple trailing closure syntax, controversially. SwiftUI is again, it's just a really, really different way of doing things. And one of the reasons I emphasize that so strongly is because that is something it has in common with working with Swift on the server. It's a completely different way of doing everything. But where SwiftUI still is designed to express user interfaces and work with the services of the operating system, Swift on server is something very different. We have mature Linux support, at least on Ubuntu, and more of it coming. We have official roadmap saying that Windows support is coming. And a lot of Windows support actually works now as it happens. There's a few things left to work out as far as that goes, but it's going to happen, I think. There's an entire Swift on server work group that's whose job is basically to maintain a set of packages and help new packages be developed and improved to the point where they're useful in a widespread sense to create an entire ecosystem. Again, and this not entirely differently from the way that more familiar web frameworks like Ruby on Rails and Node.js already have. But the goal of the Swift on server ecosystem, the workgroup especially, is to create a stable, strong baseline, something reliable, and something that's less a roughshod or haphazard as some of those ecosystems have gotten. This explosion emoji in the background here, I don't know how visible it is in the stream right now. That's the official emoji logo, so to speak, of the Swift backtrace package, which handles, well, let's see, on macOS, when Swift crashes for whatever reason, say a fatal error, you get a backtrace in usually Xcode's console or a crash report, and it's symbolicated, or at least you can symbolicate them after the fact. But on Linux, by default, as things currently stand, that doesn't happen. So the Swift backtrace package is provided to fill in that gap. And that's something that's one of the kinds of basic services that the workgroup wants to provide in the ecosystem. There's also packages for things like dealing with logging or in metrics, analytics, telemetry. And then there's the NIO project, which it's a framework that's, well, read the slide, it's been meticulously designed to make networking and I/O in general stable, reliable, and safe on all the platforms, which is no easy task. But doing, and more particularly, handling it asynchronously and correctly, which almost nothing does right in the current climate. Nothing handles networking quite correctly. It's a very, very difficult thing. On macOS, NIO is able to use the newer network framework, also called transport services. On Linux, it does not use libdispatch on Linux, although libdispatch does exist there. It uses threading more directly because it turns out that's more efficient on Linux, at least for working with servers anyway. The reasons for that are pretty complicated. NIO is extremely powerful, very, very complicated. But it's also it's maintained quite meticulously by very, very skilled team. And I should probably mention that the rocket emoji is there because that's the unofficial logo for NIO. Why they picked the rocket, I have no idea. I couldn't think of anything better myself, so I'm one to talk. And last but not least, there's the one thing that makes Swift on Server a practical tool that you can use right now, and that's a framework for building a web server. NIO provides the base for creating a server in the networking sense, an HTTP server. But Vapor provides all of the infrastructure that you get, again, from other frameworks like Laravel, Node.js, Ruby on Rails, things like that. Vapor is the Swift version of all of that. And it's version 1 and to a certain extent version 2 were kind of heavily based on Laravel. Version 3 was starting to get away from that a little. With version 4, we've gotten a much further distance away from that. It's now a proper, completely independent framework in its own right. It's that's another one that has a very dedicated and skilled team maintaining it. I count myself among them proudly. And they're not affiliated with Apple, but we do have how to say we do have a member on the Swift on Server workgroup team, core team, and we have a lot of contact with the NIO team, which is part of Apple. So there's a lot of support behind this kind of endeavor, although Vapor specifically is not supported by Apple as such. Right now, as far as I'm aware, Vapor is more or less the only mature offering in this space ever since IBM gave up on development of Kitura. So it's kind of nice to be the only one at the moment. About history, less about specifics of why I'm sure that is better kind of Swift on the server. And to this point, I know I haven't said much of anything about that. Goodness gracious. So there's no UI frameworks, no UIKit, no Swift UI. There's things that you could call user interface frameworks, such as templating languages. Vapor has one, but that's not quite the same thing. It's a framework for defining a way to present content, not a framework for integrating with an existing platform interface. And the difference is, among other things, that it is designed, it has the same advantages that Swift on Server itself does. So you can move on. You don't have, you can use Foundation, but it turns out for a lot of things, Foundation is slow. Foundation can be really slow. I mean, really slow. Part of the problem is that web services have to scale. I mean, you don't have to use it just for the web services. I've been getting a little too specific about that. It's a network. You can host things other than HTTP servers, even with Vapor, much less with Swift in general. It's just that that's the most common thing that people are looking for because it's used to implement API servers as well these days. There's no Objective-C interoperability because Objective-C, at least in the form that Swift understands it, it doesn't exist on Linux, or for that matter on Windows. There's just no need for any of that. And that means there's a number of constructs that you just don't see in Swift on Server, my favorite being class inheritance. Everything in Swift on Server, well, almost everything, but just about everything is protocols. Some of you may know the term protocol-oriented programming, which Swift is very fond of in general, and Swift on Server follows almost religiously, I might say. And that's because it works better than inheritance for things that Swift is good at. And once again, it's faster because inheritance requires, partially for legacy reasons, but also just as a design choice, class inheritance requires reference types, which means all of those benefits of value types and enums, enums are value types, but the specific kinds like structs and enums, all those benefits of Swift and all its power, you can't get them with inheritance. You can get them with protocols. There are differences and there are difficulties, but by and large, it works a lot better in Swift. And as I've mentioned before, there's an ongoing effort for supporting more and more platforms, which means that the language is constantly growing in directions that aren't specific to its inheritance of being built by Apple and first released on Mac OS. And there's nothing wrong with that, but it does mean that it's not limited to that. There's also no ABI stability requirements on Linux, because generally speaking on Linux, there's no ABI stability. An argument could be made either way, but by and large, there's no need to hold back on compatibility questions. So feature adoption gets really, really fast. Swift gets a new language feature, it's ready to use on Linux pretty much immediately. The same can't necessarily be said of things that are being written on Mac OS. There's a lot of things that are specific only to Mac OS since Catalina, for example. I can't think of one off the top of my head. I know they exist, though. The Swift Crypto package, for example, is one of those because it's based on the CryptoKit framework, which only exists in Mac OS, Catalina, and later. And as I've mentioned before, there's an active ecosystem supported very explicitly by Apple, with incubations by the Swift Server work group, and they are active. It's not just a group in name. Like the Swift core team, the work group core team meets regularly and actually does things. And I don't know how many of you that would be a surprise to, but it was certainly a surprise to me at first. And we've also found that projects running on the server, and Vapor has been a big, big presence in this regard, makes the evolution of the language happen. Not entirely differently from how SwiftUI did, in fact. SwiftUI has, as I mentioned before, made new features for the language just to support it, but fixes and improvements in the language have also been driven by the needs of the Linux user community. Another great thing about the Swift on Server is NIO is cross-platform, Vapor is cross-platform. All of this stuff is, well, one form of what Java used to advertise as the write once, run anywhere idea. And Java failed horribly at that, as it turns out. But for server applications, I mean, Windows support is coming. You can run a Swift-based server app just about anywhere, at least in theory. And when problems come up, fixes get made, and it helps everybody. We've had a lot of bugs get fixed that turned out to be problems on macOS too, even in old apps like AppKit and UIKit-based apps. The Swift standard library has a lot of algorithms in it that would be familiar to people deeply versed in things like category theory and who got very high grades in data structures class, which was not me. But the algorithms turn out to be really, really well suited to use on the server. Data processing is something that a lot of API servers do, with or without a database behind it. And Swift Standard Library provides a lot of really nice support for that. Uh-oh, looks like I forgot to do a 12th thing. Yeah. Come on, Keynote. I don't know how many of you recognize what song that's from, but there are certainly some drawbacks to Swift on servers. Well, nothing's perfect. Nothing can be, I mean, whether or not Swift is well designed for the server world and the Linux world in general, it is still at its core originally a macOS and Apple design project. So there are always some issues, and anything has issues, especially anything is new with Swift, and even newer as the web ecosystem for Swift. As I mentioned before, there's no ABI stability on Linux, but that's also a drawback because it means you can't make certain guarantees about updating things. And that's less of a concern on Linux in general, but it matters just the same. And of course, if you're doing things with the server-side type things on Mac OS, it becomes a problem there. The ecosystem is brand new, so there's a lot of immature projects and things that aren't quite ready. I called Vapor a mature project, but Vapor 4 is just been released. Not all of its components are GM yet. That's true of most of the projects still being incubated by the work group. We don't have async await, which for those of you who recognize it, refers to coroutines, the ability to express in the language itself that something is not going to happen right away, but you'd like to resume your control flow at the same point that you started waiting for the asynchronous event to finish. This is used in other languages, most notably things like Python, and I cannot remember for the life of me what other language I remember it from. But the problem is Swift doesn't have that. And as a result, right now we end up with NIO providing chaining of futures instead, which involves lots and lots and lots of closures. And the compiler has historically been very cranky at us for that. A lot of those bugs have been fixed in Swift 5 and especially Swift 5.1 and 2. But there's still some quirks to be dealt with, especially around type inference and Xcode syntax highlighting. Their cross-platform behavior is not as consistent as it should be. Write once, run anywhere is a nice dream, but even when you're running the same libraries on every system, there are differences. And that's one of the things that's been holding back Windows, I might add. There's plenty of the competitors. Again, I've mentioned several of them already, the Ruby on Rails, Node.js, and breaking into an established space like that is hard. We don't have binary distribution for those projects for which it matters. We don't have good support for scripting using Swift quite yet. Core Foundation, which I mentioned Foundation before, but Core Foundation, as most of you probably know, sits even further underneath that. It's written in just C, and it's a very old, venerable, and complicated API. Well, not necessarily complicated, but cumbersome would be a better word, maybe. And I wish I were joking when I say even more, but I'm not. There's always lots of things to deal with. And anything is good. Anything has its ups and downs. As I was saying, or at least I think it would be silly to call something perfect anyway. I don't know how much of this slide and the animations is visible in the stream. I hope all of it. I put enough effort into this slide just for the fun of it. Xcode, yeah, Xcode's got a lot of problems. Swift on servers, it reveals a lot of them. But I can say, in my opinion, based on my time at Apple, it's inevitable that Xcode has problems. And I don't mean to belittle the engineers at Apple who have been doing a lot of great things with it, but that doesn't change that there are some issues. I'm running a bit over time than I expected here, so I'm going to go through this pretty quickly. This is a good Bugs Bunny quote, and the bare minimum you need to get an AppKit-based app running. Obviously, I've left out a few pieces like the storyboard, for example, but this is largely an AppKit app that opens a window that has a single button in it that disables itself when you press it and then re-enables it periodically. There's a lot of obvious weaknesses with the way that this has to get expressed in Swift, like all of those implicitly unwrapped optionals for the IB outlets, or for that timer for that matter. That happens because we have to do all the setup and view to load instead of in an initializer like Swift is expecting. And of course, we see the legacy of just how old AppKit actually is. Property names like isEnabled, which comes from Objective-C, that completely spurious sender parameter in the IB action. Might not be spurious in some applications, but it certainly is here. Or the app delegate taking notifications for the parameters of the delegate methods. Here is the UIKit version of exactly the same thing. And despite being more modern, UIKit ends up needing even more code to do the same thing, enough so that I imagine it might be pretty hard to read on that screen. And of course, I've had to compress it down to fit on one slide, so it's horribly formatted. Absolutely would never write code that actually looked like this. But some of the problems are gone. Some of the ones like the implicitly unwrapped optionals are still there. You just need all of this boilerplate to work in UIKit, and less so in AppKit right now, but more so overall, as it turns out, in the long run. And here is the Swift UI version of the same thing yet again. And this does not need a separate storyboard. It's more or less completely self-contained. I left out the preview renderer or whatever the heck it's called. I must admit I have very little experience with Swift UI so far. I don't remember what everything's called yet. But Swift UI uses all the newer Swift features, property wrappers and function builders and closures, and all of this just screams, look at me, I was designed for use with Swift. Literally Hello World program for Swift on the server, specifically Vapor. And this is more or less the minimum boilerplate you need to set up an API server that stores a single type of model in an SQL, whether SQLite or not, I don't know. Use features, and it supports creating leading the to-do created so far. And unfortunately, the only field that this little example supports is a title, because that's all that would fit on the slide. There's some other bits of pieces of code that don't fit here, like the package.swift, since Vapor applications are packages, which is one of the major advantages of Swift on server. Everything can be a package. good luck packaging up a Mac OS executable that way, although I suppose it's still possible. So as the screen goes blank on me again. So I don't know how many of you recognize this quote, but I'm sure you're wondering either way what the heck it has to do with Swift on server. And hopefully it was obvious throughout a lot of this that there was quite a few bits that I didn't mean to be taken entirely seriously. All the facts are true, or else I wasted a lot of research time. But if any of you are taking all of this as some kind of incontrovertible proof, then that's the wrong message to take from my presentation. It is much more that, how to say, the intent is to show that there's a lot of different ways to approach things and that everybody is going to find different things more comfortable. And really, if nothing else, sometimes you just got to have fun. And I hope certainly this slide demonstrated that. I mean, despite the tone of some of this, I take Swift very seriously personally. And I stand by my thought that it is at its best in the server, that it gets the best use, the most value out of that environment, at least as things currently stand. I have contributed a lot to the server ecosystem, and it's been my privilege to do so and to be part of the larger Apple community. But especially one of the things I took away from working at Apple was if you can't step back and laugh at things sometimes, you're in trouble, because you need to be able to do that to get sometimes there is just so much going on and so much going wrong and so much that's broken and can't be fixed, or there's just no chance and no time to fix it. And Apple especially was a very intense environment, and things that you would call disasters come up all the time. You have to laugh at it or you're not going to survive. But I think my underlying point is that it doesn't matter what kind of, it doesn't matter which ecosystem you're having fun with or which part of Swift you like the best or whether you like Swift best. Among others, some people like Rust better, no counting for taste. As long as you're having fun and enjoying what you do. And on that note, I give you my very last slide. And thank you everyone for tuning in. This was a lot of fun to set up, and like I said, I really hope it was obvious that all the kind of excessive joking was very much on purpose. It was a very specific tone that I hoped to set. I hope I did a good job, but if you're going to mess it up, and I hope I didn't, then this is the way to do it, by having fun anyway. Thanks again. See you all later.